In this final section, we're going to take a look at how we can utilize the rules of inference to be able to verify or refute argument forms validities. And we're going to use a little bit more complex than what we looked at before, complex examples. In other words, when a truth table is not going to be useful, we have to rely back on the rules of inference. And the rules of inference, just to remind you, are on the worksheet that looks like this. And we're going to be focusing on these rules right here. And using these rules, we're either going to be able to verify or refute an argument form of higher complexity than we've seen with truth tables. So here's the trick as to how we do these sorts of things. The way I always start these is I look at the most simplistic argument form of the premise. All right. So you don't want to look at the conclusion, because what we're trying to do is we're trying to validate or refute the conclusion. So for right now, just pretend that this doesn't exist. All right, because you don't want to use that in your when you're building these. And what we're going to do is we're going to build argument forms and hope that they look something like one of these 9 that we have down here. So that's the goal. Now the letters might not be exact, but we want to make sure that at least fits the form of what we're looking for. All right, so in this first example, start with the easiest, which is not T, and try to look for something else that has a T in it. And these two right next to each other have a not T and a P implies T. And we can get an argument form out of that. So I'm going to call this 1. All right, we're going to justify each step as we go along. So step 1, we have P implies T, which is given, and we have not T, which is also given. And therefore, that's going to yield not P. And how do we know that? Well, we're going to go back to this sheet, and it says that if we have P implies Q, so Q is the conclusion, P being the antecedent. If we have the negation of the conclusion, we get the negation of the antecedent. And so that's what we have. We have the negation of the conclusion, and so that's going to be not P, and that's going to be by the rule modus tollens. All right, so that's how we're going to do this. We're going to build these arguments just like that. All right, so we're going to use this worksheet, and here's our modus tollens. All right, now we're going to use this not P. All right, so now notice that we have a couple that contain a not P, but we can't necessarily say anything about R yet because we don't have R. All right, so at this point, it's probably not going to be useful for us to even try to work with this argument, okay, or this argument form. But this statement form right here, not P or Q implies R. So we have not P, and that's from step 1. We could say that therefore we have not P or anything else, all right? And if we look right here, so notice we have some statement. That means as long as one of the statements is true, then we could have not P or Q, not P or not Q, whatever it might be. All right, but as long as we have something that we know is true, we can just throw an or on there. All right, so this is going to be not P or Q. All right, and we can say that by generalization. So go back here, and the rule is generalization. All right. And that's a powerful one. So this is so our generalization. And now we can use this not P or Q. All right, so we're done with this guy almost right here. This not P or Q. So what's given was not P or Q implies R. So that's given. We have not P or Q, and that was from step 2. And therefore, we're going to get R. And remember, we look at our rules again, and we have this modus ponens. If we have the antecedent and the conclusion, if we're given the antecedent, we get the conclusion. All right, and that's exactly what we have right here. We have the antecedent, we verified it from step 2, so therefore we get the conclusion. So this is modus ponens. All right, so now we can deal with the R. Now, at this point, we have not P and we have R. So we should be able to get to not S, and we can. But first, we have to build the form not P and R. So we have not P from step 1. we have R from step 3. Therefore, since we have not P and we have R, we have not P and R. And what's the justification for that? Conjunction. So if we look at our conjunction, where we have one statement verified, we have another statement verified, that means we have both statements verified conjoined by an and. That's called conjunction. And we're almost done with this. It's okay to cross out the statements once you've used them. So we've used this, we've used this, we've used this. Doesn't mean you have to cross it out, but I like to, just because that way I know I'm done with it. I might come back to it, but in this case, I'm not. Right? So we have not P and R implies not S. So we have not P and R implies not S. Well, we have not P and R. So this is given. This is from step 4. And then therefore, we get not S. All right. And that's by our modus ponens again. And we're almost done. So now we're done with this guy. So then we have S or not Q to work with. All right. So we have, for our 6th step, we have S or not Q, and that's given. From step 5, we got not S. All right. And then finally, what can we say? Well, if we go back, so we have P or Q. In this case, we have S or not Q. And we don't have P, or in this case, we don't have S. All right, so notice we have S or not Q. We don't have S. One of these has to be true, so therefore not Q. And I believe we call that elimination. So take a look at elimination, P or Q. One of those is true because it's an or. If one of them's not true, then the other one has to be. All right, so in this case, that's by elimination. And we're done, because if you look all the way back up at the beginning here, not Q was the conclusion that we wanted. Okay, so we're going to say that this is a valid argument 4. One final example, and you might wish to pause the video and try to work through this on your own, just to make sure you understand it. But if you're kind of lost from the last one, maybe a second example might be helpful. But I always do suggest to students to try it on your own, see how far you can get, and then when you get stuck, to go back to the video and to try it on your own again. But we have another argument form, and again, we're going to start with the most simplistic of the premises that we have, which is not W. Ultimately, we're hoping to get to not T. Well, we have also U or W. All right, so we have U or W, but we don't have W. So we have not W. So this is given. This is given. And remember, we had the elimination. All right, so therefore we have U by elimination. All right, and if you don't believe me, we can go back to our sheet. And remember, elimination says that we have U or W. We don't have W, so therefore we have to have U. All right, that's exactly what we have here. All right, so we can cross this one, we can cross this one. At this point, let's use this guy because we have U. And anytime you have an antecedent, you can go to the conclusion out of it. So step 2, we have U implies not P. We have U, so this is given. This is from step 1. Therefore, we have not P. And you might remember this one is the modus ponens. Right? Sorry about my handwriting on the screen. I'll try to make it look at least in English as much as I can. I don't know if that's any better, but it is what it is. All right. So done with this guy. We can use modus ponens again right here because we have not P from step 2. Right? So it's okay to use the same steps over and over again. So we're going to have not P implies Rn not S. We have not P, so this is given. This is our step 2. Therefore, we have Rn not S. All right, and that's again modus ponens. All right. Now we just have to use this T implies S. And we don't want anything to do with R. R is not going to help us at all, because if you look, the only things that we have left, if I erase all this, and I'm going to zoom in, I'll zoom back out after I'm done. But notice that we just got rid of this guy. We got rid of this, we got rid of this, so we got rid of this. So we only have this to work with, and we need to get to not T. All right. And if you go back down, we have this R and not S, but we really don't care about the R. All right, the R doesn't do anything for us, but the S does. So let's get that S out of there. So in step 4, we have Rn not S. All right, so that was from step 3. Therefore, well, if I have both of the statements and they're conjoined by an and, I can pick either one of them. Well, the only one I really want is not S. Right? So therefore, I'm going to say not S. And of course, we need to justify that. And that's going to be right here by specialization. So we have P and Q, therefore P and Q, therefore Q. So if you have an and, you can pick either one of them. In this case, we just want the not S. So this is by specialization. And now we can use that last premise, T implies S. So we have, for step 5, we have T implies S. We have not S from step 4. So this is given. This is our step 4. And you might remember modus tollens says that if you have a conditional statement and you have the negation of the conclusion, therefore you would have not P, which is the negation of the antecedent. And that's exactly what we have. We're going to have the negation of the antecedent, which is not T. So that's going to be our modus tollens. All right, and we're done. All right, so, and we're done just to make sure we understand why we're done, because we were looking for the conclusion of not T. So this is a valid argument form. All right, so similar to the Boolean algebra or the basic logical equivalencies, these usually give students a little bit of headache while they're working with it. So a suggestion might be is to make sure you can work through both of those problems that we just did in this video on your own, and then try to work through the assignment problems. Or if you're studying for your examination, then try to do the sample exam types of problems. All right, so this is all for chapter 1. In the next section, we're going to start building up more of our syntax by looking at quantifiers and qualifiers. But for right now, just use this to be able to work on your assignment number 1, and make sure you email me if you have any questions.